Okay, so earlier, I talked to you guys about, okay, how can we use technology to use Empirical to find the measures, to find the percentages, knowing measurements, knowing the X measurements. Okay, I mean, we saw the technique, but now the question is, okay, but what if I was asked to go the other way? What if I had standard deviation, or what if I had the percentage, and they were asking me, okay, how can I find what measures fall within that particular standard, within that particular percentage? It would either be the bottom percentage, in between percentage, but we're going to just go ahead and keep to the in between one for right now. The bottom one we could figure in the future, but right here we're just going to go for because we have to couple percentiles, but we'll see that in the future. I'll do problems on those guys in the future. But right now we're going to work on the middle ones. That's what we're going to work on for right now. And that's what happens in Empirical. Anyways, so over here, notice how the problems doesn't change. It's the same as we did before. So you want to catch on to it, look at the previous videos, and you see it happen. Come over here, we notice that our mean is supposed to be, well, I'll read it again. So the weight of candy canes are bell-shaped, so normally distributed, with a mean of 32 grams, which we're going to put as X bar, because we're using this from a sample, and standard deviation of 6. What two weights does approximately 99.7 of the weights fall between? That's interesting. So notice how we're not going from X to percentages. We're not doing that no more. What we're doing here is we have a certain percentage, and we're trying to find the X's. Okay? We're trying to find the X's this time. So we're literally going backwards. So here's the coolest thing that we're going to see here. It's pretty tight. Well, I'm going to show you here, and also how to use technology to get it done. But notice how when we for tech, when we talk about tech here, okay, we had tech. We saw that if I was going to have measures and I want to use technology to get percentages, I had to go to pretty much distribution, and I had to go to normal, CDF. The normal CDF, which pretty much led us to the formula to be, oh, and I'm running out of space, crap, which led us to the formula to be the normal CDF, okay? And once again, our end is small, we had a lower, we had our upper, and we had our mu, and our standard deviation. It's stopping right here, I know it is. But that's what we had there, and we saw that earlier. But hey, if I have to go the other way around, notice I'm inversing operations, I'm going the opposite way, inverse. So instead of going for the normal one, I'm actually going to the inverse one, and we'll see that. So it's going to still, I have this thing called it's black right here. Okay, black. So what we're seeing here is what we're going to do is, well, if I'm trying to do percent to this, I'm going to still go to distribution, because it's always under distribution, but instead of going to the normal one, I'm going to go to what is referred to as inverse norm. Okay? I'm going to do this one. I'm going to do the inverse of the norm. And this is what's going to happen here is they're going to do something different. And what's going to end up giving us here is going to end up giving us something that is referred to as it being, well, first it's going to say inverse norm. I'll put inverse word. And inside here, the first thing they're going to ask for here is something it's going to be the area, but we can put, it's going to be area. So I'll write area. Okay, right? Area. Okay. Which in our case, we're looking at it being the proportions. Okay, proportions. The proportion sum. And they're going to ask, okay, what's your mean? So that's mu, it's going to ask for standard deviation. Okay. And over here it's going to ask for direction. Direction of tail, okay, or direction of region. So right here it might be right. But also depends on your calculator too, guys. Some of you guys can't do this. So watch out for the limitations, okay? So it might be right, it might be left, or it might be center. Okay. But these don't have a review. And that's a TA4 and Inspire. Others won't have this option. Some of you guys, this right here will not be given to you. So you have to figure out how I'm going to figure this out then. Okay, and we're gonna see in the calculator. But that's what's happening. So I know for a fact that the Casio and the T84s does all this, but for the Aspire and the original T84s that are not the newer versions, or T83s, it doesn't have this. So how do I deal with it if I don't have that option? Okay, but it's okay, we'll see it happen. But anyways, we're gonna show by hand what's happening, where's the system coming from, and then how technology works, how we get technology. So I'm sorry for that extra stuff, so once again, pause the video, note that down, that's what's happening. I should have done over here, where I have all this work, but I was twerking with the skeleton. But I didn't have to do the skeleton because I was showing it in the previous video. But I know what's happening here, this is going to be changing right here. So at least this guy right here will be changed. I'll write it right now. So what we're looking at now is supposed to be the inverse norm. And it will be area, which is what we refer to as probability, or proportions. Supposed to be mu, standard deviation, and then here is questionable. Okay, it's questionable. And we'll see that. So like the rate result was over there. So over here, Casio, okay, and TI4 okay, has left, right, center. Okay. While, okay, I should put in here CE edition. Okay, I know that definitely has it. The CE edition has this. But the other tier first, other TIs, including the Inspire, okay, it's only going to have that. It's default to that. I won't see that. So just have that noted there. Wait till the calculator, we'll see that restriction. I promise you. So just keep that in mind for you guys, whoever's watching the video. So the numerics is good. Beautiful over here that I did earlier. It was nice, but I need the space. Okay. Anywho, here we go. So our job is to find, once again, I'll read the question. So the weight of candy canes are ball shaped with a mean of 32 grams and standard deviation of 6 grams. What are the two weights? What two weights does approximately 99.7 of them fall between? Okay. When usually we're saying middle, but sometimes they'll say middle. But we're here, we're seeing it is empirical, but middle would be the better way of writing this question. The middle, 97%. Okay. But anyways, we're seeing here. Well, where's 99.7%? Well, if you look over here, it's right here. It is the one that is within 3 standard deviations. It's these guys right here. So I'm dropping over here into these regions right here. So if you already know your empirical rule and you set it up, I know the answers. Okay? We probably don't know the answers because it's always going to be in the middle. So what we're saying here is the two grams are probably saying the answer is going to be pretty much between it's going to be between in this case 14 grams and 50 grams. And that pretty much is our answer. So it's between 14 grams and 50 grams where 97% of the candidates are going to be. So that's pretty much how you get it straight from the answer, from empirical rules. After you set it up appropriately, that's what you have to do. But let's go ahead and come over here and say, okay, fine. How does this calculator? I gotta get over here. I gotta get this guy over here. Bam. So once again, I'm doing opposite of what I did before. So percentage to x values, I have to use inverse. So simply what's happening here for the Casio, let's turn the second on. I'm going to set the quiz, you know what's happening. So remember, you have to be in statistics, you have to be a manual, it's already having statistics. So we're in statistics, and in the main menu, we see distribution right there. So hit distribution. And we're still in the normal, so we hit normal. And I double clicked it. Go back, exit. I do have heavy fingers, so I have to watch out for that. So normal. And there it is, inverse norm, right there, inverse norm. So I'm gonna hit that. And now it's gonna ask, okay, is our central, do we have a central tail? And if you look at it, we do have a central tail because over here, what are we looking at? We're looking at all this. We're looking at all this right here. Looking at all that. So we have a central tail. Okay? So the other thing that is two-tailed. Central tail, two-tailed. So we're in the center, so we have that, and we're supposed to get at the 99 point, I can't speak, but the 99.7%. So all we do is convert it into proportions, which is your area. That's what we're seeing there. And our mean and standard is the same. Okay, we input it in. So ours, we have central. So we have the option over here to put central. Like I said, for the conceal and for the TI-84s, you have the option for central, which is right there. So now, to make sure it looks good, well, can I graph it? Or you can't really graph it, but you could calculate it. Okay, and what's saying here, the lower x for the inverse distribution is going to be 14, exactly 14.193572. And if you round this off to the nearest candy, we're looking at 14. And it matches to what we had in our table. Similar thing for x2. This is going to be the upper one. So this is your lower, this is your upper. And it says right here, 49.8064276. And if I round this guy to the nearest candy, I get 50 when I round it. So I'm coming to the same answers when I round it and using technology. So this was table. Using technology, I get the same answer. So I'm still looking at between 14 grams and 50 grams. You see that? See that? Pretty cool, pretty nice. So that's what's happening there. Well, do I have the same limitation on my TI-84s? No. So I'm going to do TI-84s right now, and you're going to see we're going to get the same. We have the same options. What? Oh, I should show you the right tail. Smart guy. But I'll come up over here real quick. Distribution, normal, inverse. Over here, the tail, you have your options right here. I forgot to show you that. Smart guy. But just right here. Okay, you have left tail, right tail, center. Okay? So this is where you put your options. And which tail you're looking at. And are the central, because we're talking about the empirical rule. And let's specify otherwise. Anyways, so that was this one. I just want to put that one out to you. That I forgot to show you where it was at. It's right there. Okay? Now, TI-84. Let's bring you guys into the mix. Okay. So those new TI-84s, we're going to do the same thing. So let's just second quit it real quick. Second quit, get to the main screen. Don't worry about this. But you know, you still have the same answers when you do it. But it's cool, you get it outside. But come over here. Get me down a little bit. There we go. What we're going to do here, same thing. I got to get to distribution. So I'm going to do second distribution. Bam. And over here it says, no, I don't want to do, I can't graph this one, okay? I only graph the percentages. So I have to go here to inverse norm, which is option 3. And what it says, what's my area? Well, it was supposed to be the 99.7%, right? So when I convert it into proportions, I'm looking at 0.997. My mu, well, my mean is supposed to be 32, so for 32, and my standard deviation supposed to be 6. And it says right here, what tail am I looking at here? Am I looking for a left tail below? Am I looking for a right tail above? Or am I looking for the middle 97.7? And per rule is middle. We're talking about the middles. So we're looking at the center. So that we enter and select center, and now I can paste it. And it's saying all this. Okay? Maybe in your TID course, you might be able to go back, or Inspired, you might be able to go back and type this in, but that might be a little tedious. Okay, it requires more work. But anyways, it's here. We say center, and when I press enter, it says, whoa, here we are. We're looking at 14.193, same crap. Same thing. When I round this to the nearest value, I'm still getting 14 again. And here's my upper. 49.806 and on. For round this guy to the nearest candy, I'm also getting 50. Remember, these are guesstimations here because we're talking about amounts. Okay? So therefore we have the same answer. That is amazing. So now, how am I going to help those people who don't have it? So what we're going to see here is I'm going to show you what's happening right here. Because what I'm going to do, I'm going to go up there. I'm going to get the center. Okay, this is what's going to be. This is what the other people are going to be seeing. Those are the other TIs right here. The other TIs with the R right there. The other TIs, or even this bar, you'll be seeing this. They won't say left, but it's going to be a left, and we'll see that. Watch. So come over here. I'm going to come up here. I'm going to copy this guy over, enter. But I'm going to delete the center part. This guy's gone. I'm going to delete it. And I got to get rid of the comma too. So this is what permanent early calculators are limited to. Those who have the TI-84s, you're limited to this. So now when I actually enter this, oops, sorry, delete, put the parentheses, and I enter. Notice how it only gives me the lower. So what is really happening here? It's only doing the left tail. Okay, that's what we're doing here. So if I were to go back to the distribution calculator, we'll see it happen. I'll show it to you, okay? Guys, I'm going to show it to you what's happening. So I'm going to go back to second distribution. I'm going to go to my inverse norm. But instead of doing center, I'm going to choose left. I'm going to paste it. Notice how I say left here, and notice how I'm getting the same result when I enter. I get the exact same result. So I'm knowing that for my calculators that are limited and I can't write the stuff in here, or the writing doesn't work, we should understand that when it stops right here, it's always left. It's always going to be left. And that's going to happen for all the other TI-84s, or all the other TIs, or also 84 silver editions, and also for the Inspired. It's going to happen. So watch out for that. And now pretty much we'll get to it right now, and we'll see what happens for TI. But I'll show you guys what's happening for TI-84s. The other one. So the way I'm going to do the Inspire, you do it the same way. Okay? I'm going to try two birds with stones. So I'll show you this guy here for MTIs that doesn't have the option for left, right, center. It's always a left. Keep that in mind. So when I see the Inspire, we're going to do the same thing happen. Inspire time. Like always, just do a new page. So a control, document. And right here, you don't necessarily put it into the stats, we'll just put it in the calculator. It's going to be easier to see it there in the calculator, so we'll put it in the calculator. Then you could do all these guys in the calculator, but you won't be able to graph the calculator. That's all it's in stats. If I'm trying to graph it, get the percentages, going from X to normal, to percentages, the graph is in stats. Over here, just do graphs. So, now, I'm going to do menu, I'm going to go to my statistics, and I'm going to go over here to distribution, where it is right here, no, option 5, distributions. And there it is right there, inverse normal, right there. And this is where I come to see and realize, oh, notice how I don't have the option for a left, right, center. Crap. So what this is, it's always going to be a left. Keep that in mind. So, what you guys got to do is you have to get the corresponding left tails. Left tail and right tail for the most part. That's what we're going to do. And I'm going to show you over here in this side before I even do this, because we have to know what that crap is. So, for you guys who are doing the other calculators, you're going to catch on to, hey, Where's my left toe at? This is my right toe, so my left toe has to be over here. So my left toe that I'm looking at here is right here. Left tail. And this is for the one that goes to the 0.99, or I should write here, the 99% middle. Or I should put the center. Come on, you got it right, better. Let me change the other way. Center, this is better. Center, okay, 99.7%. This is the left that corresponds to it. Okay, so there we go. Because now we can figure it out if we want to get the left toe. I could have done that real quick. You can say, okay, well, what is it? Well, it's going to be 100 minus the 99.7. Okay, but once again, I'm supposed to get half of that. Okay, and when I do that, this is just another way of doing it. I get half of it, so I divide that by 2. And we're probably looking at almost the same thing. Over here it has those 1.13, right? Over here is 1.15. Which is pretty interesting to see that it's a little bit different. Okay? But anywho, if you're going to go based off this guy here, we have that. If we're going to go based off technology, we have that. So understand, it's slightly different if you're using the table, because remember, the table is an approximation, it's not the exact. Okay, just watch out for that. So I'm going to skip to the table for right now, because that's what we're looking at here. So why did I skip it? Menu, back to statistics, back to my distribution, my normal, my inverse normal. Okay, so now I know my area for the right tail. If I use the empirical rule, it's going to be my 0.013. Okay, I just move the decimals over to the right, to the left 2 units. So we have that. Next, coming down over here, my mu is 32. Okay, and my standard deviation is 46. Okay. Now when I enter it, this right here gives me the left area. Notice how for this one here, keep in mind, it is smaller than the one before. Okay, and why? Because remember, this is not really that accurate. Because once again, there's more over here that we should keep in mind. And that's one thing I think that's not missing here is the extra ones. But come over here. What if I did the 15? Would it be a little more accurate? Well, I'm pretty sure it would be. So notice come up here. I'm going to copy between over down. Notice how I just went up and selected it. And now what I'm doing here, instead of putting 13, I'm going to put 15. Okay, which should be a little more accurate than the empirical rule. Notice how it's going to give me the exact same answer that I got earlier. Where's my spider? I'll tell you for it. See it? Okay. Interesting. What did I do wrong? I'm doing it wrong. Oh, why did 13? There's 13 over there, huh? It is. Okay, we're good. Well, over here says that what should be the value? Well, it should be 14. Over here rounds up to 14, over here rounds up to 14. Okay. What should be the same thing? Oh, because I was looking at the wrong number. I think it's something else. And notice we're reading the same thing. Okay, I'm sorry about that. I was looking at something else. I was tripping. But here it is. The same one for the left, the lower. You guys see that? Yeah, my father's over here. Oh, that's what I gotta do. I forgot to I proved it to you. Anyways, sorry about that, I got distracted. Anyways, so from here, what's the issue? Okay, well, over here, we notice that we only got this tail, and I found this number. I wasn't doing these, I was doing exact numbers. So how am I supposed to get this guy over here? Anybody? Well, I don't know. Okay, but one thing we should have known here is something called symmetry, right? Over here, we know in this region, this is your right tail. That corresponds with the same one. So if I want to try to find what, remember the TID force, everyone just this left. So our job is we can't figure this guy out unless I know this. Yeah. That's what it's saying. So one get this right, the delta that corresponds with this right tail. That's all we're saying. And that's not bad. All we're doing here is we're getting 100, and I'm subtracting the right percentage from it. And this would equal my left. Okay. If we sum the two up, it should be the whole 100. And that's what we're going to do for yours. And you're going to see the answer. Watch. Check it out. Here it comes. So I'm going to go back to the original one. Okay. So I guess the 15 is a little more accurate because that was what the analysis supposed to have been. This one here was a little more accurate, so I'm going to click to this one. But we're doing the same thing. So I'm going to go back to my menu. I'm going to go to statistics. I'm going to go to distribution, inverse. So now for the area, what I want to do here is I'm going to get my 100, or in this case, it has to be proportions. So I guess I have to turn it to proportions over here. I should have thought about that. But if I'm going to do this work, what we're seeing here is we have 100% minus your 13 for what's happening over here. 13.3%. And when you actually subtract this, you should end up pretty much getting, in this case, well, I can't do math right now, but it's going to be 99.97 if you're using the table. But if you're using the calculator, tech, there's going to be 0.15 here, which would have ended up being just 99.95 if you're using the tech. So that's what I'm going to do over here. I'm going to convert that percentage into proportion. So I'm looking at pretty much 0.9995 to be the more exact one, using the technology. Over here, it's going to be same thing, 32, and over here is going to be 1. Sorry, 6. So now what we do, we're getting the corresponding left toe that's going to match the right toe. So when I enter it, notice how is it wrong? No, it's good. Fully 52, right? Fully 52. Much of it. That was 650. Interesting. So this is what happens when I come over here and put it with the empirical. Ooh, there we go, enter. And I put the empirical one, which is going to be the 7 instead. So delete 7. Okay, enter this. Is my math wrong? My math is wrong, guys. It is 8. Smart guy. Somehow I can't do my math, guys. Let me just do it by hand. I mentally I did it wrong. I'm sorry. I do have errors. I'm not perfect. So 100 minus the 0.13. It's supposed to have been 87. I put 97 on the board. Badger name. That is my fault. Oops, let me just move here. Is it that one? Delete 15. Okay. Badger name, okay, I'm gonna fix it. So up in here, instead of it being the 9997, okay, or the 995, the more exact one, I was supposed to have that 9985. Okay, so watch out for your math, don't be like me, messing up like that. But enter it, now it makes sense. I'm like, how am I getting that? Something happened wrong with my math. Something happened wrong with my math. So now we're seeing it there. So when you round this off, it becomes 50. There we go, dang. Once again, I'm not perfect. I do apologize, I do make errors. Once again, I'm doing 3 different technologies, so I'm learning them all at the same time. But literally, that's it, right there. So for any other problems, do the same work, okay guys? Sorry for doing, another one for this one here. But that's it. If you want to try the 60, look at the 60, try it out, understand how it works. But the most important thing is, for those who are not the Casillos, or say the newest Casillo, because you might have to do it for the older Casillos. I don't know yet, because I don't have that calculator. You guys have it. So know your restrictions. And those who have the other TIs and the Aspire is this guy. If you don't have left, right, center, you're always doing left. So you always got to keep in mind about this left idea. Left is left, but if you want to get the right, just get the complement. 100 minus the right. Or 1 minus right is in proportion. Okay? And that's all we're doing there. So other than that, practice it. Once again, practice makes better. The more practices, the more I'll most likely not make as much little tiny errors as before. But before I even erase, do things over here, I'm going to fix my little errors over here. 8 and 8. Okay, that is totally my fault. I didn't notice it that I wrote 8. I might have also calculated 9 in my head. I was supposed to be 8. Okay, but other than that, you guys are good. So practice and get more efficient to it. Okay, bye, and thank you.